Hello students, I welcome you to Structural Analysis 2 subject. Okay, so here we are going to start with chapter 1, that is Basics of Structural Analysis. And here we are going to cover a specific topic, that is degree of static and kinematic indeterminacy. But before we move to this topic, let us see the basics. What is the basics of structural analysis? So what are the types of structures we have considered? We consider for the study. So let us see the forms of structures. Now, since you are semester 3, you have studied beams, trusses, arches, cable structures. So we have covered it in last semester also, right? So these are the typical structures we we study uh, during our engineering, and they are actually we use our study. It is its application is in practical world. It's in outside. So the beams you have studied. So what are the types of beams? The beams are simply supported beam, fixed beam, then there is a continuous beam, overhanging beam. So what does this beam do? Beams, they actually transmit load to the supports, right, mainly through shear or moment. So we have studied by considering lot many, whatever simply supported beam you consider, and then when some load is acting on the beam, then we used to calculate what is the shear and bending at each and every point, right? So whatever load is acting on the beam, right, vertical load or inclined load, so that is taken care, that load is being resisted in terms of shear and moment. Okay, then there is a structure. Now when beams are generally used for the small span, now when spans are very big, when that particular structure is having really a huge span, so in that case we use trusses, right? In that case we use trusses. So how does trusses work? So trusses, they transmit load primarily by axial forces in members. Okay, so they transmit load by axial forces in members. So suppose if there is a truss, if let us consider this small truss is there, and if some load is acting here, some load is acting. Okay, so all axial members will be acting, axial forces will be there in the members, and the top chord will be under axial compression and bottom chord may be under tension. And then there are arches. So for specific purpose we use arches. It's the shape of the arch, the circular shape of the arch. So whatever load act on the arches, it actually helps in reducing the bending moment. Okay, so because it also arch also, uh, because of arch there is some thrust, horizontal thrust act over here, so it does not allow the expansion of the arch, and there is actually a reduction in the bending moment. So arches are also very useful. So we use arch structure for the large span, and even we use the cable structures. But the difference between two is here forces are in tension instead of compression. Like arches, mostly forces are in compression, but in for cable arches, the cable it will be under tension. Okay, so these are the forms, and there are again more types of structures. So do you remember? Can you guess what are the other types of structures? So there are again frames. We see the frames, and there are also shells elements. So before we see those structures, let's see few pictures of these. So these are the before we move to the pictures, let's just see the types of frames. Frames are of three types, that is industrial frames, multi-story building frames, and building frames with shear wall. Okay, so industrial frames, we have seen the industrial frames, like if you see, the in Delhi Auto Expo is very famous. So beautiful industrial frame structure you can observe there. Um then multi-story building frames, even in airports you can see the frame structure. Then building frame with shear wall, so this is during construction you can see. Then there is also shell structure, cylindrical shell and hyperbolic paraboloid shape structure. So shell structures are there, but this is out of your scope. So they are also wonderful structures. So we'll see the pictures, how beautiful shell structures are there. So coming to the, I have just kept few pictures, So these are the beams. You are aware we already studied the beam structures. So this is a simply supported beam where one support is hinge and other is roller support, and some load. Load can be of any type. So it can be a point load or uniformly distributed load or varying loads, and it can be a uniformly varying load. It can be kept in a different pattern also. So this is a cantilever beam. This is simply supported beam and this is cantilever beam. Again here the different combination loads are shown over here. So whenever some loads are acting, because of that we try to calculate what is the shear force and bending moment at any point. Okay, so we calculate reactions and then we find out the shear and bending moment. So these are the beams. So trusses, coming to the trusses. So this is a typical Warren truss. Okay, why do we call it as a Warren truss? There are different types of trusses. So what is the speciality of Warren truss? All this every member of the truss is at 60 degree. Okay, so you can see here all members are at the 60 degree. So this is just an example I have kept. It is a form of the structures. So the top members will be under compression and bottom will be under tension. So this is a beautiful example of arches. Okay, so I have taken it from the network, internet. So these are the beautiful examples of arches. Then you can see the cable bridges. Okay, so cable bridges. So these members, they are under tension. Then frames. Okay, as I said, there may be industrial frames, there can be building frames. Okay, we can see a industrial frame and then we can see a building frame. So different types of frames, and then frames, what was the third type I just now I said, frames can be, building frame with a shear wall can also be there. Okay, so these are the types, and see the beautiful picture of shell. Okay, so the shell, it's so interesting, civil engineering is really interesting once you understand that how it works and how do we design it. So this is the basic forms of structures which exist in reality, and for this particular structure analysis too, we are going to touch till the frames. Okay, so we will not be considering shell element. Now coming to our topic, the basic understanding of what is determinate and indeterminate structure. Okay, so determinate structure, what is determinate structure? A structure can be analyzed by using equations of equilibrium, is called as statically determinate structure. Okay, so what are the equilibrium equations? So summation of forces, okay, summation of forces in x direction is 0, summation of forces in y direction is 0, and summation of moments are 0. Okay, so these are the three basic equilibrium equation. You have to remember it very well. Okay, because for all the problems whatever we are going to solve, we are going to use this. So what are the basic equilibrium equations we use? Those are 3 in numbers. Okay, to make any structure determinate, we should solve the problem using 3 equilibrium equations, and these are those equations. Okay, so that is a property of a determinate structure. Second point, that indeterminate structure, because of change in temperature, if there is any change in temperature, it will not contribute to the causes of stresses. Okay, so there will not be any extra stresses developed if there is a change in temperature. So this is one important maybe assumption you may say, or characteristic for a determinate structure. And then third point, no stresses will be developed due to lack of fit. Okay, so if there is, suppose if this is a one beam, and if there is some joint, if there is some displacement, this is going down with some distance. So if there is a lack of fit, because of that there will not be any stresses in the member. Okay, so that is our point. Then what are the examples? Okay, so these are the examples of determinate structure. That is, this is simply supported beam, you can see a cantilever beam, and 3-hinge arch. Okay, 3-hinge arch, if you remember, a arch with supports which are hinged. These are the hinge supports and there is one hinge over here. Okay, so that is a determinate structure, 3 hinge charge. Okay, now let us see what is indeterminate structure. And essay 2, structural analysis 2, mostly it deals with the indeterminate structure. Okay, so the first characteristic is structure cannot be analyzed by using conditions of equilibrium, is called a statically indeterminate structure. Okay, so these 3 equations are not sufficient to solve a problem. So that's why it is called as indeterminate structure. Statically indeterminate structures means we need more equations than these to solve the problem. Then second point is the stresses are caused due to change in temperature. Okay, so if there is a change in temperature, then stresses will be counted, okay, for the indeterminate structure. Coming to third point, stresses are developed due to lack of feed. Even there is a lack of feed, stresses will be developed. So that is one important point. Then, yeah, this is repeating. Then what are the examples of indeterminate structure? So this is a fixed beam. This is indeterminate structure. We cannot solve this beam using these 3 equilibrium equations. Okay, so this is indeterminate structure. So why it is so? Because summation of force here it is 3 reactions, right? One vertical, one horizontal, one vertical, and one rotation. Vertical, horizontal, and moment. So there are 6 reactions. So we cannot solve it. Okay, it's a indeterminate structure. So we cannot solve this. And then this is a propped cantilever. Propped cantilever is also a indeterminate structure. Okay, so this is a fixed end. So here 3 reactions, and for propped cantilever there will be a 1 reaction. So total reactions available 4, and what we have available is 3. So 4 minus 3. So this particular propped cantilever is actually indeterminate to 1 degree. Similarly for fixed beam, it is total reactions, that is our formula is R minus 3. Okay, we call it as ds. Anyway, we are going to solve this problem, but I am just telling it in a short time. So here 3 plus 3, 6 reactions are there, minus 3, 6 minus 3 is 3. So this particular fixed beam is indeterminate to degree 3. Okay, then there is a 2 hinge charge. So 2 hinge charge is nothing but this is the arch, and then this end is fixed, hinged, and there is other end is also hinged. So this is a 2 hinge charge and it is a indeterminate structure. This 2 hinge charge, when there is an internal hinge, it becomes determinate. Okay, so this is about determinate and indeterminate structure. Now let's see the formulation. Okay, so we are going to use beams, trusses, frames. Okay, so what are the formulation for this? So I want you to see here that if it is a 2D truss, okay, if it is a 2D truss, in that case our formula will be degree of static indeterminacy. Okay, we can also write it as ds, or we can also write it as dsi. Okay, so that is equal to m plus r minus 2j, whereas m is a member, then r is reaction, j is number of joints. Okay, and in case of internal hinge, it is shown by h, or even somewhere it is shown by I, somewhere it is shown by n. So any notation is okay. Okay, any notation is fine. So when it is a frame, okay, if it is a 2D frame, then our formula becomes 3m plus r minus 3j minus h. Okay, so the formula changes for the frame and the truss. Okay, now if it is a 3D truss means space truss, it is a space truss. In that case our formula is m plus r minus 3j. Just see the difference. When it is a 2D truss, it is m plus r minus 2j. When it is a 3D truss, it is m plus r minus 3j. And for the frame, 3D frame, our formula is 6m plus r minus 6j minus h. Okay, so you have to remember these formulas and there won't be any mistake. You have to simply substitute the values. How many number of members are there? How many reactions are there? How many joints are there? What are the internal hinges? And you will be with the answer. Okay, so this is about statical indeterminacy of the trusses and frames. This table was specifically showing that. Okay, now this is a basic formula. Degree of static indeterminacy or degree of redundancy, that is actual number of unknown reactions minus available equations of equilibrium minus number of internal hinges. Okay, so what are the actual number of unknown reactions that we have to see? How many unknown reactions are there? Then what are the available reactions, available equations of equilibrium? So mostly if we consider here that actual number of unknown reactions, if it is called as R, minus available equations of equilibrium will be 3 minus H. Okay, so this is the formula we are going to use. So what is degree of static indeterminacy? Degree of static indeterminacy or degree of redundancy is equal to actual number of unknown reactions minus available equations of equilibrium, and in case if internal hinges are there, then we will be counting them. Okay, so this is a general formula for degree of static indeterminacy. So students, I hope till this point you must have understood. Now let us see a definition of degree of kinematic indeterminacy. Okay, so degree of kinematic indeterminacy. First of all, I want you to remember that degree of kinematic indeterminacy is also called as degree of freedom. Okay, so don't get confused. Degree of static indeterminacy, we have set formulas. With that we will going to find out what is the degree of static indeterminacy. For degree of kinematic indeterminacy also we have formulas, but I want you to understand the concept. Okay, what is the degree of kinematic indeterminacy? It is also called as degree of freedom. So the number of equilibrium conditions needed to find the displacement components of all the joints of the structure is known as degree of freedom. Okay, now for the free end it is 3. How it is 3? Just see with the example. Suppose this is a cantilever beam. Okay, this end is free. Okay, so what will be the degree of freedom for this? So this free end, it is capable of a translation movement. Okay, it can go like this. It can also have a rotation, and it can also move in this direction. Okay, so there are possibility that it can move in 3 directions. Okay, so that's why degree of freedom, okay, it is free to move in 3 direction. So degree of freedom or kinematic indeterminacy is 3 for this. Now let us consider a other example. So let us consider a simply supported beam. So here in this beam, roller support. Now roller support, we know that it carries a equation 1. Okay, it is capable to resist load in vertical direction. So it is the capacity. Okay, so don't see it as a kinematic indeterminacy. I am trying to tell you that roller support is capable to take a vertical reaction. Okay, but then where it is free to move, so it can have, it can move in a horizontal direction, or it can also have a rotation. So rotation and the other horizontal direction movement. So roller end will have 2 degrees of freedom. Okay, now let us see what happens with the hinged end, hinge support. So hinge support, basically it is capable to take vertical reaction, uh, vertical loads and horizontal load, right? We know that hinge support is having 2 reactions. Reactions are 2 for this. Okay, means if it is capable to take a vertical and horizontal reactions, then what will be its kinematic indeterminacy? It cannot take moment. So rotation is possible over here. So hinged end is having kinematic indeterminacy is equal to 1. Okay, so this is the understanding. Now if it is a fixed end, so for a fixed end is capable to take a vertical load, it is capable to take a horizontal load, and it is also capable of taking the moment. So there is no scope of rotation for this, there is no scope of any movement for this. So kinematic indeterminacy or degree of freedom for this fixed end is equal to 0. So hope these 4 cases are clear to you. So the number of displacements allowed at the joint of a structure is called as degree of freedom. Okay, students, so hope you have understood this, and in next class we are going to solve the practicing. We are going to do more practice on these topics. Okay, so thanks for listening to this class. Thank you.